Hello everyone, my name is Daryl and I work as a software developer, and today we're going to be continuing TIS-100. This is a game where you code with a fake assembly language. It's easier than x86, but it's pretty fun. So in the last episode we went ahead and did the first 3 levels here. So let's go ahead and start level 4, Signal Comparator. This one, so read a value from in, so there's just one in here. Write 1 to out G if in, so we're going to get to use some jump statements here. Let me just open up that page. Okay, I'm going to need this. But write 1 to out G, so there's G, E, and L. If greater than 0, write 1 to out E. If in is equal to 0, write 1 to out L. If in is less than 0. When A1 is not written to an output, write a 0 instead. Okay, so if in is greater than 0, then it's going to be outputting 1, 0, 0. Yeah, it's always going to be inputting a 1 in one space and zeros in the other. So of course it's interesting with this one that we can't use these. It's interesting there's only one debug on this. Interesting. Okay, so I'm thinking on how we're going to do this. So probably the way it's going to end up working is we're just going to be passing this value down to here and through to here. And essentially it's going to take the data from in is going to take the path of going down and all the way across. And it's going to end here. And when it gets to this node, it's going to go ahead and do this check and either output a 1 or a 0. Then it's going to just pass the raw value over to here. It'll do its own check, and then it'll pass it here and do its own check. Of course, I don't really like that we're having each node separately do its own checks, because if we determine here that this is a 1, it's kind of dumb for us to waste processing in this node checking if it's equal to 0, because we, with the logic, determined here that it's greater than 0. But I am not aware of, especially with these being blocked out, I am not aware of a way, right now at least, that you could save that processing. So we'll see how this plan works and how it shows on the efficiency charts at the end. So here it's going to be pretty easy. Just move up, down, move up, down, move up, right. Now here, we want to move left to ACC. So if the value is greater than 0, then I'll put a 1. So we want to do JGZ, so jump if greater than 0 to GZ, which will make a label. We'll make that later. Otherwise, okay, we'll do this. So that will jump there. Otherwise, JMP, no. We'll just say no. And I'll explain this in a moment. So GZ, we want to move 1 to down. JMP end no will be move 0 to down. And then here we just move ACC to right. Well, that's kind of annoying. Let's just put that in another line. Okay, so quickly explaining what I'm doing here. So we're going to take the value we get from the left and put it into the ACC register. If the number in here is greater than 0, we want to jump to this label, GZ. So let's kind of go with that logic. So the number is greater than 0, so it's going to go here, and it's going to output 1. Then it's going to jump down to this end label, where it's just going to move ACC to the right, so this node can process next. If we go here and it's not greater than 0, it's just going to continue. And we're going to jump it to this no label, which is going to output 0. And then it's going to still just go on to here and move ACC to right. And to be honest, these other nodes are going to work very similarly, just using a different here. And actually, I kind of want to change this to yes, just so it's a little more consistent. And then I can kind of use the same thing for here. So we're going to move left to ACC. And if it's equal to 0, so that's JEZ, yes, JMP, no, yes, we're going to move 1 down, JMP end, no, we're going to move 0 down, end label, move ACC, right. And just so you know, I'm using the single line syntax for the labels when I can, because it's just kind of less lines and it makes it easier to read. But in this case, I didn't have enough characters to write move ACC right after this label because I was 1 character short. So I just moved it to the next line. And we need to put a space there. This is going to be very similar. So move left to ACC. This is going to be JLZ, right? JLZ. Yes. JMP, no. Yes. Move 1 down. JMP end. No. Move 0 down. And move ACC right. Well, actually, we don't need to move ACC right at this point. We still need to have that label, though, because we need to have, right here, we need to have this jump down to here. So let's give that a shot. Looks like it's working. Let's do fast. All right. So, wasn't too bad. I was near the most efficient. Everybody pretty much figured out how to use the same amount of nodes. And my instruction count's not bad either. Not the best, but not bad. All right, so let's go ahead and do the next segment here. So that's going to be signal multiplier. Oh man, they added a lot more of these that I unlocked here. And this is new. What is this? Simple sandbox. I think the sandbox one, where did I see that in the manual? I think that is that the visualization mode? Or no, there was something in here. Yeah. In that last section that talked about, image console sandbox as a larger visualization module. So maybe that's it. But anyways, let's go to signal multiplier. I'll do that one next. This one, read values from in A and in B, which are these ones. Read a value from in S. Write in.A when in.S is equal to -1. Write in.B when in.S is equal to 1. So there's only one output. Write in.A plus in.B when in.S is equal to 0. Okay, this sounds like fun. So we're probably going to want to read from both of these and then in.A. Write that when that is. Okay. So, yeah, okay. All right, so this one's going to need to... This one's just going to read from up to right. This one's going to read from up to left. So it's going to take it and offer it to this one. This one's going to move up to ACC. And then when this one's going to be kind of a longer node. So JLZ A. So if it's less than 0, we'll go to A. JGZ B. So if it's greater than 0, we'll go to label B. And then otherwise it'll be here. If it's here, then I want to move right to ACC and add left, which is going to add it to that value. And then we'll say JMP. Now here, we're going to say at A, I'll go to the next line for this, because it's not going to be a single line thing. If we have A, then we want to actually probably want to, let's go ahead and do move ACC to ACC to down here. And here, we are just going to move left to down. B, well, then we're going to want to JMP end. B will move right down, and well, then we'll go ahead and just put end here. And end will just, well, do we need it? Yeah, we still need end there because it's going to jump to there. So the general idea is move the input to ACC. If it's less than 0, then go to A, which will just take left and pass it down because we want to use A. If not, it'll go here and say, hey, is it greater than 0? If it is, because it's a 1, we're going to just take the value from the right and move it down. Otherwise, if neither of those are true, it must be 0. So we'll need to take the right one, put it into ACC, and then we're essentially taking the left one, adding it to that, adding these together and storing it in ACC. And then we're going to move it from ACC down to here. And all of these, they just need to move up to down. And here, just move up to down. Let's try that. Ooh. We got some errors going on here. So the first two worked fine. I'll need to step through this here. So the first two were fine. Now, what happens right now? So right now, this one's here. This one's being offered up. Let's see here. Let's restart that. So these are all here. These all ran at the same time, right? Or we're still going. Okay, now they're both being offered up. It's going to see that it's less than 0. Oh, yeah, we forgot one step. One step that we need to do when we go here, and I'll go, well, we'll leave that there for now. We need to move right to nil. And for this one, we need to move left to nil. So if in the case of A, we're going to take the left value and just move it down, but we also need to accept that right value, and we're writing to nil, which is just like a garbage space. It's not going to actually do anything. We're just kind of accepting the input and trashing it, basically. But we do need to do that. There we go. Now it's working better. Let's go ahead and do fast. All right. So we didn't get the most efficient. We did average, which is interesting. Although we did best with the nodes here. And we did best with instruction count. But there's a more efficient way with more instructions. That's interesting. All right, I think we're good on that one. All right, I think that's going to be good for this episode. We did another couple of them. They were a little bit harder. And next time we'll continue with this sequence generator one. All right, thanks for watching. Catch you guys next time.